Good evening to all. I, on behalf of our President, Sri G.S. Khuntia, uh, and other office bearers, I welcome you all to this edition of Fraternity Presentation Program, where our members, they speak based on their knowledge and experience for the benefit of the geoscience fraternity. And today we have very distinguished member, Mr. Ramanath Praharaj, who is a known mining engineer in the country, and he would be speaking on the challenges of underground mining in SUKINDA Valley, where we get 95% of our country's chromite from that valley. So I now request you, our Vice President, Sri Alok Bihari Panigrahi, who is a former Controller General of Mines, IBM. So he is one of the foremost expert in the mining activities in our country, who would be taking us through the entire presentation, where he would be introducing the speaker as well as do the honor of moderating this session. So I now request Mr. Alok Bihari Panigrahi sir to do the honor, sir. Mr. Panigrahi sir.
Thank you. Thank you, Jadavandau. Good evening to one and all. This is an online program, and I see many of very experienced persons from the industry and from the academia also. This is the fifth lecture in the fraternity presentation series, and since I see most of the members are from SGT only, just for the information of members who are not from SGT. A brief introduction about SGT. It started in the year 1980 by a few geoscientists, and it was mainly for the cause of geoscientific studies and sustainable mineral development activities of the state of Odisha. It started with very few members, and now it has more than 900 members. The society has two flagship programs, mostly involving the students. For the senior students, it is the Mineral Development Awareness Program, and for the school students, it is the Environmental and Mineral Awareness Program, which is being held for more than last 35 years. So these are two programs where we develop the students on the awareness of environment and mining. The society also conducts seminar periodically and workshops annually. It publishes a bulletin biannual bulletin. Every 6 monthly, a bulletin is being published with all very highly rich articles from the experienced technical and scientific persons. The society also has written a book, which is a sort of reference for the students, teachers, and the government. That is the Geology and Mineral Resources of Odisha. And this book is being updated periodically. And the last one was in 2021 during the COVID period, if I remember correctly, and it was, I think it was by the governor of Odisha that we got it released in 2021. Okay, and the society also prepared a vision document from the government of Odisha. I think somebody is there is some disturbance. Okay, thank you. The society also has prepared a vision document for the government of Odisha twice. With this, let me introduce the speaker who will be speaking on challenges of underground mining in Sukinda Valley of Odisha. Mr. Ramanath Praharaj, an eminent mining engineer, holds an MTech degree in mine planning design with distinction from IIT ISM Dhanbad. After having initial education in the School of Mines, Keonjhar. He is the holder of first class mines manager certificate holders of restricted category. Unrestricted category. He has started his career in OMC as a graduate trainee in the year 1985, then worked in Indian Rare Earths as a mining engineer for 6 years before joining Indian Metals and Ferroalloys IMFA. He rose to the level of Vice President IMFA, where 2 open cast mines were converted to underground mines, chromite, one being semi-mechanized and one is trackless mining. These 2 mines are Nuasai chromite mines and the other is Mahagiri chromite mines in Sukinda Valley. He also worked for a brief period of 3 years in Indonesia for acquisition of a high GCV coal mine. He joined OMC as a director of technical project and planning and retired in the year 2021. In this period, he was associated very closely for the development of underground mining in OMC for the South Kalapani chromite mine. He was associated with the right from planning with SRK England probably. He is a life member of International Society of Rock Mechanics, Mining Association of India and SGT. Before we start the challenges of underground mining, a brief about the chromite mining scenario in the country and how the underground mining is going to play a very important role. Chromite, as we all know, is a very important ingredient for stainless steel manufacturing. And India produces about 3 million tons of chromite annually, which is used mostly for stainless steel manufacturing. The import is, India has also started importing, I think in the year 2024-25, about 0.25 million tons of chromite was imported, mostly probably by the Jindal Stainless Limited. Now, this chromite is mostly used for the stainless steel manufacturing through the ferrochrome charge chrome route. Now, every ton of stainless steel requires, if we convert it properly, about 0.8 tons of chromite feeding to the furnaces for metallurgy. And as we understand, the figures are not very firm. India is consuming around 4.8 million tons of stainless steel. And the requirement of stainless steel is going to rise, say at the rate of 7 to 8 to 9%. 7 to 9% in the ensuing years. That is going to create a gap. Because the chromite which is coming from Sukinda Valley mostly, the Boda Nuasai belt, which started underground mining way back in the probably 80s, that has almost come to a halt except the Bangur chromite mine of OMC, producing hardly 50,000 to 60,000 tons. Now, entire ore of chromite is coming from Sukinda Valley, which is producing 3 million tons. And now, it is very important to note that the Sukinda chromite mine of Tata Steel, which was one of the biggest producer of chromite, has been closed. So that was producing around 1.5 million tons. That has put already a pressure on the existing market. And unless the chromite production is boosted, there will be shortage in the chromite supply. And in Sukinda Valley, the open cast mining almost has reached the limits in all the pits. So underground mining is inevitable. Only underground mining which started is it has started in the Sukinda Valley in the Phekar Katpal mine also, but now it is undergoing in Mahagiri chromite mine of IMFA, which was also in which Mr. Praharaj was also associated. Then another important development is the band 1, which is the friable band of the Sukinda Valley, containing the maximum reserves. The IMPA is starting their underground mining in the band 1. That they have already, I think, started the decline, and SAP probably is, or SAP sinking is also under progress. Hekar has started something in Mostapa, but OMC is going to go in a big way. About 1.5 million tons has been planned from South Kalapani chromite mine, in which Mr. Praharaj was associated very deeply. Also now Mr. Praharaj is the advisor mines to Jindal Stainless Limited, where Jindal Stainless is also planning to go for underground mining in Sukinda Valley. So with this brief background, may I request Mr. R.N. Praharaj to deliver his lecture, and those who have any questions, please send it through the chat box. The chat box is open, so you can ask your questions at the end of the presentation by Mr. Praharaj. We will take up the question and answers. Mr. Praharaj, please.
Okay, thank you, Pandey sir. Honorable President and members of the SGAT and all other members who have joined this fraternity lecture. And Pandey sir has already given in brief the scenario of chromite in the country. What I will be discussing is one of the major issues that is creating a mindset in the mind of is a bottleneck in the mindset of the operators for going or switching over to underground mining, which is quite reasonable. Also, if you look at the way villages have been distributed and the kind of reserve they have. So, without wasting much time, now he has already told in brief for the information of all the members. South Africa and Turkey are the largest producers and exporters of chrome ore, with Kazakhstan possessing the largest reserves. Chromite as a crystalline mineral is primarily composed of iron oxide and chromium oxide compounds, and it's an important ingredient for production of stainless steel. As chromite is converted to ferrochrome, which is used in stainless steel making. That is why it has become a strategic mineral. But I think, or I guess, in another decade's time, it will be converted as a from strategic to critical mineral. And this is the distribution of the world reserve. And in India, 96% of the total reserve is located in Odisha in Sukinda Valley, and a small reserve is located in Vasai Baula sector, and 0.93 and 1.94% of the reserve are located in Nagaland and Manipur respectively, and so also very meager 0.05% in Telangana and Tamil Nadu. Let us look at the distribution of the leases in the Sukinda Valley. There are geologically 6 bands which have been reported, but so far mining is continued mostly in band 1, as Panigrais have told. It consists of about 55% of the total reserve. This band is very rich in grade and quite wide and almost continuous. And because of the folding, which has happened in the South Kalapani lease of OMC, in the old portion, the ore body is quite wider. And interestingly, the plans of the fold also varies from 25 to 40 degrees, which is another challenge because different methods of mining will be required there as compared to other portion of the band. So if you look at the issues, sorry. So many mining operations in the Sukinda are conducted on small leases, and because of the small leases, the scale of operations are definitely small, which affects the economy. And few of the leases are going to expire because which were allotted prior to 2015, and they would be completing their 50 years term, will be expiring by 3035. And namely, the ones which come to our mind is South Kalapani will be there, then Ustpal will be there in 2035, and others will be following. And many of the mines, as told by the Panigrahi sir, they have almost reached the optimum pit level, and they are unable to expand because of the restrictions on public roads or lack of space for overburden dumping. So this actually necessitates that we must think and plan for underground mining. Planning for underground mining there because for agents, sorry.
Any projection? Wall projection?
I'm not able to hear. Can you please come back here?
No, or
No.
No, sir, please continue, sir. There is some disturbance. Please continue.
Okay. Okay. So the time required for finding out the feasibility study for underground requires considerable time. If the lessee has not carried out systematic exploratory drilling, then it is going to take a hell of time, and quite a good amount of money is also required for that. And these studies will be involving geotechnical studies, mineralogical studies, hydrogeological studies, geotechnical studies. So once you do that and you come to a conclusion that underground mining is feasible, then probably you can plan the underground mining. And this once you decide for going underground, the development of access to the ore body, which is the first action in reaching an ore body, maybe in the form of decline or shaft, requires time. And there are other factors like transition from open cast to underground. This requires upfront investment in infrastructure, in manpower, and these small companies may not be interested in continuing or investing so much of money whose leases are likely to be expiring in shortly. They may not like to invest in that. And the major bottleneck is the band one, which contains about 55% of the reserve. And always there is a hitch in the mind of many of the mining engineers that the issues involved with underground mining, like there may be some incidents involving roof falls, or there may be inundation, and as such the working conditions are adverse. It's not very conducive as compared to open cast mines. So these are the things which actually create a bottleneck in the mindset of the operators. And if you think of this band one is quite continuous, almost 5 kilometers in length, and is reasonably wide, varying between 10 to 35, 40 meters at places. And this continues to great depth. In fact, in OMC South Kalapani, they have located it for about 900 meter depth from the surface. And IMPA has also drilled up to 900 meter. Baleswara has drilled up to about a kilometer. So the persistence of the lease at depth is already established. And what are the opportunities if you look for going underground mining? IMPA has already started underground mining in the year 2009-10. Now they have stabilized their underground mining operation in Mahagiri. They have already started developing underground mining in band one. They're going for a combination of decline and shaft. Similarly, Ostpal, which is now being operated by Vedanta, they have also started developing underground mining. They are going with two declines, and then those things will be connected with shafts or ventilation. I am told in another month's time they will be touching the ore body. So they are also now, these are becoming examples for others, that if others can do, we can also plan. and reserve is already established. And now slowly, slowly, a culture is developing, underground work culture in the area which was hitherto not there, is now slowly developing. And the skilled persons who were initially hired from outside of Orissa, mostly from Rajasthan and other areas where underground minings are prevalent. Now slowly the local guys are also getting trained because the demand for chrome ore is going to be there as the consumption in stainless steel grows. We must think of going for underground mining. Now let us discuss a bit about the geology. There are 6 chromite bands. They are occurring in different strategic periods. Stratigraphically, band 1 is positioned at the core of the plunge, and it's a synclinal fold, and it is considered as the youngest one. Other bands like 2, 3, 4, 5, and 6, they are occurring sequentially away from the fold axis and becoming older in terms of their disposition towards Mahagiri. Out of all the bands, band 1 is the thickest, and as I told, it contributes about 50% of the total reserve. Band 2, 3, 4, 5 have also undergone folding during fast phase folding, and the ore bodies gradually swing to west and extend. During second phase of folding, the deep of the ore bodies have become subvertical, which also causes the variation in the width of the ore body. Area has undergone multiple phases of tectonic deformation, which is evident in when you see folds, faults, joints, and innumerable number of shear zones. So this is basically the geology. When I was talking about band 1, now just I'm showing a schematic diagram of underground mining. Just it's shown to give you some idea that there could be a vertical shaft. This is there can be a decline. There can be ventilation shafts, ore bins, things like that. But with the open cast workings will be on the top of it, and below that we can go for underground mining. And this portion which is above, sorry. So this red line which I have drawn, an imaginary line, and above this is all soft or semi-hard. If you want to reach the ore body, you have to pass through this strata, this soft zone and semi-hard zone to reach the ore body. As there is no currently no mining method is available in the country which can handle this friable, very soft powdery ore. And ore is like this, so also the host rocks, both Hangwal and Footwall are very weak. Literally, if water comes in contact, it becomes smart. So I will show you 2 cross sections of the area just to give you an idea how much is the uh, effect of the weathering. This red line which I saw, above that, it is all soft with literally zero RQD, and better not to talk about RM and things like that. Below that, between this red line and the other line, it is the called transition zone, which is somewhat semi-hard. At places you get little bit soft, little bit hard zone. And below this blue and violet line is all fresh rock and hard zone. So what we should plan is to reach the ore body below this hard zone, which comes around below minus 300 to minus 350 mRL. That means if the surface area is 150, roughly about 450 to 500 meters, you have to pass through to reach the ore body. And obviously, you will not like to drive through these soft zones, because that will not only be expensive, time consuming, also somewhat risk is involved. So you have to plan to start the underground mining somewhere the ground is a bit of stable condition. Let me show you. This is a cross-sectional section, transverse section of the ore body, almost perpendicular to the strike. There is another cross-section. This is in one of the mines. Here you can see how the ore body is surrounded by soft and moderately weathered rocks. And this RL will be, of course, around above -250. If you just see, it will be around -250. -250 to minus below, you can try underground mining. And the ore above that has to be left as such. Whatever is possible, you can take out through open cast mining. The rest all will you have to leave for the time being, which will act as a ground pillar. Now, before you start driving the underground drivages or declines or inclines or shafts, since it is a very soft ground, you have to first stabilize the ground. And I am just showing one of the examples where the ground is very soft, as you can see. So what we have to do is, how do you deal with this soft zone? There are methods available nowadays. Mainly, how do you stabilize the ground before driving in? There could be mechanical stabilization. Basically, this is for surface structures where you do the compaction and things like that, or chemical stabilization, where you can use lime, cement stabilization, which is mostly followed. And at times you can also use, you can also add uh, calcium chloride in varying percentage, maybe up to 6%. That will give you enough strength, and mm, quickly you can do that. And but there are reports that this the strength of the ground deteriorates after 6 to 7 months. So mostly people use cement stabilization. Now, when we think of stabilization, how do you do it? I'll just show you a small video, which you can appreciate and understand the basic principles. How the
are young mountains. The rocks in this region have a lot of minor cracks inside them. In the grouting technique, we inject cement into these voids. The cement acts as a glue and the rock becomes stronger. You might have seen a lot of strange-looking blocks in construction photographs of Chenab Bridge. This is a smart slope stabilization technique called anchor block stabilization. In this method, the workers make holes on the slope. After that, they insert a special rod with a lot of tendons in it. In this project, they used Dividag tie rods. Now it's time for grouting. Once the grout is hardened, a block is kept on the rod. Now comes the use of a powerful hydraulic jack. The hydraulic jack pulls and keeps the steel tendon in extreme tension. After that, using a wedge arrangement, the steel tendon is kept in tension, even if the hydraulic jack is removed. Now, can you predict the force produced by the concrete block? The steel tendon in tension wants to reduce its length, but the block is not allowing that. This means the concrete block will press the slope inward. This compressive force will greatly increase the stability of the slope. Their necks are young mountains. The rocks.
Now, this grouting, just for information of the members, so what are the ingredients that are used in the cement grouting? This is called microfibers, normal sand, river sand, cement, and these chips, which are -7, and then steel fibers. They are added and mixed in a container and sprayed onto the ground. So with the pressure, it impinges, a lot of material goes inside the open cracks and try to hold it and make it somewhat steep and a continuous mass. And this is the picture where this material is being sprayed. So normally people, depending on the requirement, carry out shotcreting. This method is called shotcreting. Is carried out depending on the requirement, and people use at times reinforcements apart from the steel fibers. People use wire meshes, steel wire meshes. One layer they do for 20-25 mm, and then they put the steel wire mesh, and then again they do the concrete. So once that is done, the ground has become impervious, and it has become somewhat from the top. Yeah, water will not enter, which is the major bottleneck for the slope stability and all. Then what we do? Then holes are drilled. Holes are drilled. About 6 meters, 12 meter holes are also drilled for grouting. So I showed you vertical walls. These are horizontal walls drilled. You can appreciate now the previous video. We are showing the holes which are drilled from the top of the bench. And these are the horizontal holes which are drilled. Spacings are pre-decided. So now holes have been drilled, the top has been already circulated. Now inside this circulating, below this circulate, the ground is loose. How do you make it strong and compact? We have to now introduce SDA, which is known as self-drilled anchor. This is different from the rock bolts that we normally use in underground mines, in hard rock mining. And these are helical rods, which are high tensile rods, and they have standard length of 3 meter, and the size also varies from 32 to 45 mm. There are couplers where you can increase. The beat is attached to it. In the loose ground, once you drill, you are not able to pull out the beat because the hole is collapsing. Otherwise, had the ground been stable, probably we could have pulled out, and then we would have put normal standard rods or cable bolts and we would have grouted it. But since that is not possible, this self-drilled anchors are used. We might have used the small 1 inch, 1.5 inch in our house also. So this is put inside the hole and left as such. And these drill bits have 4 holes. And inside this helical rod, uh, uh, grout is pushed. And then through these holes of the bit, it passes through. As I showed in the first video, it actually, encircles the area around it, passing through the crevices, small cracks and pore spaces, and it becomes a kind of a monolithic mass in that particular area. So we have tried it in very loose rock, about 2 meter by 2 meter spacing, these rods horizontally as well as vertically, and we have grouted it. We have broken it and seen that the entire area is very nicely held. It has become a solid mass. So then once that ground is made, probably you can think of driving it in terms of underground. And this is one picture. This is a circuit machine. After doing the first layer of concreting and this SDA, then the wire mesh It's almost 4.9 mm by 4.9 mm dia steel wire mesh, 2 inch by 2 inch. It is sprayed over it, and then another layer of 25 mm of circuit is put over it, so that it becomes a solid mass, like as if we have cast a roof. And this is another picture how workers are engaged in laying those wire mesh before doing the circuit. This is a video which shows that once the holes are drilled, we put the cement out. You can see these are the helical rods, and cement is injected along with other additives at high pressure, about 7 to 8 kg. And once the cement starts coming through the crevices of uh, the drill rod, then you know that the area has been already filled with cement. This is the wire mesh I was talking about. Now, once we do the grouting of these SDAs, we also need to test to find out its strength, how much strength it is able to withstand. As you have seen in the first video, so there the rods are tensioned, pre-tensioned, because that will be resisting the tensile force, and it will be pushing from the front, so that there is balance takes place between the tensile force and this. But here we just want to check the strength of the rod which has been grouted, and this is the method we normally use. This is also required under law. So we apply pressure through hand pump, and there is a dial gauge fixed in the rod itself. So normally we achieve about 15 tons per square meter strength in this. This is a view of one of the one of the mines where actually decline is going to open. So the strengthening of top benches, as you can see, is a very fragile and soft, has already been done. These are the equipments. This is one of the concrete mixers, Ajax, and this is the grouting machine. So these are the wire mesh which are being spread right from top to bottom. Once this is done, then a box cut is made, because we have to enter to the underground. We normally prefer about 15 to 20 meter of cover above the underground excavation. So this is the front view I am showing, where I have shown that all the sides have been saturated except the portion where we want to drive. Before we drive, you can see these small dots. There is a method called four-poling. In the previous days, in very early days, people were using in Moil and that, people were using four-poling through wooden wood, which is now not possible. So nowadays, through this SDA, we drill up to 12 meter with 3 extensions, 4 extensions. We drill and we grout it. We grout it in 2 layers and with a staggering pattern, so that that portion acts as a kind of cap under which, without any support, you can enter. That is the idea. So this is the top view of that box cut. I showed you the elevation in the previous picture. So the driving will start play from here. So with this open excavation, First, we have to erect a kind of cover which is called portal. Had this ground been competent and self-supporting, probably we could have done away with this and we would have straight away driven on ground. But looking at the condition on the ground, we have decided that we should have a portal, even if it is time consuming and expensive. We decided to have a cover of about 15 meter, which acts as a kind of safe cover for any exigency. You can pull out the machines in case of sudden roof fall. You can pull out the persons. They can take shelter here. So with that intention, the portal was constructed. And the portal was constructed by using 300 MB SMB and with arch shape, because we wanted to do away with this conventional trapezoidal shape because of the pressure on the joints. Maybe they are due to abutment. So we decided it's a better way to go with arch shape. Although it is a bit cumbersome, that would have fastened the process, but this we decided to go for this. So this is how we have laid the uh, girders, and over that you can see these arches. This opening is 5 by 4 meter, 5 meter wide and 4 meter height. You can see once this has been laid, then in the top also 22 mm rod has been placed. Similarly on the ground also, we wanted to do it concrete because there will be a lot of movement of LSD, LPDT carrying load. So LSD is a load haul dumper and LPDT is low profile dump trucks, which will be carrying material from the underground to outside. So because there will be frequent movement, so we also decided to do it RCC. And as so the ground is not stable, had it been hard rock, probably we could have done away with. But we decided to do this. After this is made, then concreting was done. Then shuttering was done, and then concrete was placed. This is another view you can see. So this is the view where the shuttering is taking place from the bottom, and you can see these rods there. And walls have been completed already. About 1 meter height is done in one go, because you cannot do. It is not advisable to pour concrete beyond 1 meter height. So because there will be segregation. So we have done it in stages, and then the entire thing has to be casted. So once this casting is done, you can see the face. This has been broken with a rock breaker. Drilling blasting has been avoided purposefully because hardly there is a surface cover of about 15-16 meters, and the ground is also fragile. So this has been broken with rock breaker, and the material has been taken away by LSD. This is the finished portion of the decline, and this is the picture of just. I will show you the video of the decline. You can see in this that once when this loader is out, a face of about 1.2 meter has been exposed without any support. It is standing, although it is very weak rock, but it is standing because of the floor pulling which has been done earlier. Now the floor pulling extends up to another 10 meters. So what is the plan is that 1 meter span it will be excavated, and then concrete will be, these arches will be erected and concreting done, and slowly they will progress. Once the hard rock is reached, probably this concreting of roof will not be required, and which is expected in this particular case about after 40 meters, you will get very competent rock with a compressive strength of about 140 to 150 MPa. Progress will be better because all these hassles will not be there. So this what I wanted to show is that now we have to think, and we have to act. There is no time that if you have lease tenure available with you, it's better that you plan the underground mining operation to extract ore and take quick action. Gone are those days in early 90s, there was a slogan that underground mining is not feasible in Sukinda Valley. So things have changed nowadays with this advent of new technologies. So all the mine operators, they must plan and plan comprehensively and take decision and go ahead with aspects of it. I just wanted to cover the initial access part, which is actually time consuming, expensive, and because of this only the gestation period increases like anything. And on the other hand, vertical shaft, it is quite expensive, although the sinking will be comparatively faster, but then the capex is very high, and both the debate of decline versus shaft is going on for ages. Both have their pros and cons, and the world over the best way is that combine both like decline and vertical shaft. So vertical shaft has its own advantages, also decline. Looking at the balance tenure of the lease or other restrictions, probably people can plan for decline. So this is just an idea. With this, I thank all of you for your attention. Anto Salam.
Yes, thank you, Mr. Praharaj. There are two questions. A wonderful presentation. There are two questions, very relevant. First by Mr. B.K. Parida. He was in Ispat. Now I think he is also continuing Ispat. Parida, you are Ispat Rasundra?
No, sir, I've already got superannuation.
Okay. So he was in Ispat, and I have met with him many times from open cast to underground, everything he was associated. His question is, the stabilization of soft portion is prior to start of shaft sinking and decline. What is the depth of such grouting? So this is the first question by Mr. B.K. Parida.
Okay. So the depth depends on what is the kind of strata you are having. In this instant case, the depth is about 15 to 20 meters. And as the decline progresses, obviously the surface cover increases. Am I audible?
Yes, sir. Yeah.
What is your second question?
Yes. Shall I highlight the second question?
Yes, sir. Please.
Okay. The second one is, what are the geotechnical parameters taken prior or during the underground mining in Sukinda chromite exploration?
The geotechnical parameters, basically you determine the geophysical properties of the rock mass of the ground, as well as coupled with the joints, fractures, shear planes. All these factors you have to determine. Nowadays, software are available where you can see, how the cracks are passing. A camera in the borehole, you will be able to capture the data there. And because those actually radiate some waves which passes through, and when it encounters the crevices, it goes through that and comes back. Depending on the traveling time, the length is decided, and you get a ready-made picture up to what extent this crack is extending.
Just a minute. There are another 2-3 questions. I am not able to go to the chat box. Just a minute. I don't know how to do it. Please wait. There is another message. Yes. What is the impact on environment and environment management plan? This is by Mr. Sansita Patro. Sansita Patro. What is the impact on mining or on environment and environmental management plan?
What is its impact?
Yes.
In fact, the impact is very good as compared to cast mining, where we are polluting air, we are destroying land, we are destroying forest. Only thing here is that the water regime gets little bit of impact because you have to pump out the seepage water from underground.
Okay. Now, is there any question from the audience? I have few questions, but before that, is there any questions you can ask Mr. Praharaj? We still have a question, time for a couple of questions. Otherwise, I have a number of questions. Okay. So the first question by me, Mr. Praharaj, is what is a very interesting one, as you said, that underground mining culture is getting slowly established. So this is a very good positive setup, because underground mining is not a very easy subject. So that is the matter which is of great importance, and we are very happy about it. Second is the cement grouting. You have said cement grouting to strengthen this data, after which the area is susceptible for opening the box cut and for the decline development, etc. Now, for the general knowledge of everybody, what will be the cost of developing a 1 million ton of ore underground mining in Sukinda Valley? Number one. And number two, what is the gestation period?
Okay, a gestation period will depend on the size and length of the openings and the ground it is passing through. You see, a decline of 4x5 size with competent rock, you can safely construct in today's standard 70-75 meters progress per month, right? Whereas if you are going through soft strata, let's say 1 meter by 1 meter or maximum 1.25 by 1.25 meter, then at least you are allowing the cement to set this grouting of these arches and all. 72 hours you have to leave. So that actually, reduces your number of cycles per month. So at the best, maximum you can get 10 cycles. So almost 10 to 15 meter progress you will get. And where this support is required, the progress will be not less than 50-60 meters per month.
And cost?
Cost varies depending whether it needs full support or extra supports at junctions and all. It varies from 2.15 lakhs to, you can say, take 3 lakhs. And for the this shotcreting of, strengthening the surface cover, let's say 1500 square meter will cost you about, with 50 thick 2 layers of shotcreting with awareness, it will cost you around 2 crores.
Okay. Now, what will be the total capex? Capex.
Capex for, as I said, for a small mine like Jindal, capex will be around 180 crores.
180 crores. Okay. I have another question. This is regarding, you have touched the development part. What about the stopping?
Stopping, because I hope, because since we are trying to open the stope in stable ground, it will be like any other, normal conventional mining. It will be, you can go for, because open stope, if the ore body as well as the both the wall, hand wall and footwall rocks are competent, and because these are all steeply dipping ore bodies, you can go for that. But for chromite, as the reserve is scarce, it is always better to go for filling method. You can go for open stopes with a consequent filling, so that your recovery percentage goes up. Otherwise, it will be around, somewhere around 65%. If you go, except for the crown pillar, you can take out the reeds.
Hello.
Yes.
Yes.
Hello. Hello.
Yes.
Can you hear me?
Yeah.
Hello. Can you hear me, sir?
Yes, sir.
Sahu from Mumbai. Sahu from Mumbai. Can you
Okay,
hear
sir.
me? Yeah. Okay.
Yes.
I see, knowing very well that India has got very little chromite reserve, and Sukinda is the only source, and time may come when you require more chromite to import, maybe under political conditions like the critical minerals, we may not get it from the outside world or from outside India. Any efforts any company, any Indian company does to get the little bit of chromite from Sukinda Valley, which is the only source, is praiseworthy. And the present effort, I can see that tremendous, gigantic activities is being done to approach the ore body. This is the first time chromite is being mined underground in Sukinda. Till today, we have been mining from the surface. Now that after reaching the ore body, with all our gigantic approach, very well done, intricately done, efficiently done, we will be facing the real ore body. The problem with Sukinda ore body is twofold. Number one, it has got a thick overburden and variable overburden, and the altered weather materials which we are presently seeing over the chromite load is very soft and very variable. Ultrabasic rocks in which this chromite occurs is extremely susceptible to weathering by water. And this, to approach when you start mining the ore body, the thickness of the overburden will change as we proceed from the mine along the mine face. So our excavation, as you go on mining, will have a different parameters to meet the depth and pressure conditions of the ore body. Secondly, worst is the chromite. It's a folded structure, and the chromite is plunging, dipping. So as you go on mining, we will be meeting different depth, different pressure conditions. Thirdly, chromite ore body in Sukinda is an alpine type of ore body, extremely crushed, faulted, fractured, sheared as you go on. It's not just a strata, that it is the thickness and all the physical properties are same throughout. Chromite ore body is dipping, which is a challenging task. The thickness of the ore body is changing. Second start. Third is the chromite occurs in a body which is folded, compressed, pressed, fractured, fixtured, and altered. So with all these problems, it is necessary, of course. Excuse me, I am extending. It is extremely necessary that chromite should be available for India. And when we have got nothing outside except in Sukinda, enough work must be done. It's very praiseworthy that our people are doing to get the whatever little bit of chromite that we are having. The only thing I can add here that at the end, that having known that we have got a very limited amount of chromite, and looking at the world situation, our metallurgists must come out with something, some process to have a substitute for the stainless steel. That's the only thing I can see. I do not know what will be done, but it has to be done. Otherwise, tomorrow, well, like the critical mineral or rare earth, we will be controlled by South Africa or Turkey. And we very well know our relations with Turkey is not well, and we are not sure about South Africa. So if you don't get chromite, our stainless steel industry will stop. And when the stainless steel industry dwindle, I'm not talking about the dwindling plates and saucers we use in the home. Our defense equipment will stop producing. But I'm sure, and I really praise Mr. Praharaj and his party and other organizations who are working in Sukinda in spite of all these problems, all these difficulties. People are shouting about chromium pollution in Sukinda region, I know, but it has to be, chromium resources has to be mobilized and brought out whatever it is available there. I wish best of luck to the parties who are working in Sukinda. Thank you, gentlemen, all of you.
Thank you, sir. Thank you, sir. Now, I think Mr. Dr. Avani Samal has raised his hand. Dr. Samal, you have something to ask Mr. Praharaj?
Yes, Praharaj sir, it is a really nice presentation.
Thank you.
As a geologist, I have two questions, I think related to what House sir also raised a little bit. If we compare our chromite mineralization in Odisha, that's the only region we know, and that's the only geological region where chromite can occur. The only other country that we compete with, that is South Africa. Turkey is tiny, little bit. I mean, like Africans also talking about that, but it's not possible. If you compare with the South Africa, the chromite comes because of platinum mining, right? Because they originally went for platinum, because their steel industry is not as big as Indian. When I visited many years ago, 25 years ago, mainly it's the platinum, right? But when I was working in Bola, at that time, we knew this platinum mineralization. This little bit work has been done on that. So, Professor, any light you can throw on this aspect? Because I remember early 90s, the Platinum Research Group also visited that in a Bola mine. I mean, we did not know who they were. And afterward, there are few presentations, few papers come also. I'm very curious about platinum in Bola, in chromite. I think it's related to what also House are commented on, and also what you are talking about. When we go deeper, platinum will be running basically the cash flow for the mining companies would be coming from platinum. I mean, probably chromite is a big an element for our steel industry, but platinum would probably, bring more money to the company. And basically, I know it's a threefold kind of question. You also talked about band one. Why we're not going for other bands? Is there any problem? I know the expression is a little bit different in India, but can you throw some light on basically focusing on platinum?
Okay, so as far as other bands are concerned, the extreme southern band, which is lumpy in nature at as compared to band one at a shallow depth, is being mined by underground mine. Although the grade varies from the property in the easternmost of Tata to right up to OMC Sukrangi, the grade is different. And but people have already started. Impa is doing mining in that, and the same ore body has already been established in the portion between South Kalyapani and Impa, where the strike length is about 750 meters. 4 bands have been established. Whereas in other properties like Tata's, they have only established 3 bands, and band 2 is not continuous and poor in grade as compared to band 1, and band 5 in Tata's property, that is in the westernmost part, is very low grade. Somewhere around average grade will be 30 to 35. And band 2 also in Tata's property, it was also very low grade. Similar to at 30 to 35 degree, but it was friable in nature. But in depth, it is bound to be somewhat competent and will be mined sooner or later. There is no question of leaving it as such. And another band, which is like any other band, is friable in surface. That is called band 4 in the property of South Kalyapani and Sukrangi. If you add together, it will be about 1.2 kilometer. It's a very long and very, undisturbed ore body, 8 to 10 meter average width. And that is very, beautiful for underground mining. And I hope OMC must be thinking on that line. And as regards to PG group of elements in Sukinda, not much of work has been done. But in Baula, yes, all the 3 companies mining previously, like Packer, Impa, and OMC, they have done quite a bit of testing of samples and all. And these PG elements has been established in sulfide ore, particularly in the Sankar ore body, which is brachiated to great extent. And now factory is closed, Impa is also closed. So OMC has stockpiled those ores, something like 4,000-5,000 tons, out of which a study was given to IMMT Bhubaneswar, and for enriching the PG elements. So they have already carried out the study successfully, and during my tenure, we extended the study, saying that just by concentrating the ore is not going to help. You have to find out the metallurgical process, how it is going to be extracted. So that work is going on, and I am told by one of the scientists of IMMT recently, a month back, that the trial has been successful for extraction of PG. All the elements together, smelting. So a team was to visit to South Africa, and I have no further details on that.
I see.
Let me just throw you, just for your information, and recently IBM carried out sampling of overburden dumps, speeds, tailings of Sukinda Valley, of all the mines under that critical mineral mission. So they carried out sampling from probably month of April or February until August. Now they have come out with the report. Interestingly, the thing that we knew about occurrence of nickel in our early days, people were told that less than 0.6, 0.7 will not be viable for mining. And even in Indonesia also the same concept goes as on today. But another element, that is cobalt, from this study report, it's very amazing. I mean, you get about 752,000 ppm cobalt, apart from vanadium. So these two things, they have calculated roughly about 0.8 lakh crore worth mineral is there. I do not know what will be its fate, how it will be mined, processed, and all these things are, subsequent things government has to think. But this has been reported. Similarly, in bauxite, you know pretty well. Soilendra used to tell me long back that, sir, these laterites are bound to contain rare earth elements. And now government of India also has sponsored some projects working on those laterites. These are these are in my knowledge. So just I wanted to share.
Thank you, Praharaj, sir. Actually, just to conclude this discussion, the reason I asked you, because I'm contacted by a few ventures actually in different parts of the world for this exactly same thing, sir. I think, just to add to what you said about Shankar, even in Durga and Lakshmi ore body, when I left around 1997, around that time, I have seen a clip, these sulfide cumulates myself. I know ISM, there are two people like they wrote two master thesis on that. So this is done. I mean, is there. Chromite, platinum is there for sure. I mean, how they extract, that's a different thing. I would make a comment on, sir, the lab test in there. If you look at the lab test of extracting not only platinum, then you added actually really some other stuff, which is coincidental. There's another entity in Brazil is talking to me and a couple of us actually to help them to extract the rare earth elements, or at least evaluate the rare earth elements in their properties. Like we are in a different time. So about the lab testing, sir, I would strongly suggest, I do not know, I'm just making a comment here. Go to the lab test who have the experiences. Actually, I know IMMT Bhubaneswar, they have some testing, but who have the experiences of actually extracting this sulfide stuff from the this muddy kind of altered materials. There are some really good labs in Canada. South Africans are so, but mostly Canadian labs, they're really great. If you look at their sulfide belts and what they're doing, and they're kind of the hub for labs, and it's just amazing, actually. I'm actually directing some Africans and Brazilians also send the samples over there simply because we don't have reliable labs. I mean, that comes to my very last point. If you use a lab, know what the maximum potential for that rock. And that is where today's time, you don't actually extract all the elements. You're a loser. I don't think we have the wealth there. I don't believe that we are shortage of materials. We just need to know, like someone said, or I think a professor you said, or Sausar said, our metallurgical extraction has to actually improve, and that is where the key is. I mean, if I want to use the bottleneck, that's what the bottleneck is. Geology is not. Exploration is about actually the government policy. That's another topic. Thank you, Praharaj, sir.
Okay.
Thank you.
Hello. Can I come in?
There is a hand which has been raised by Mr. DJ Baral. Mr. Baral, please. Mr. Baral, ये माइक्रोफोनटा अनम्यूट करंतु जयवंत बाबू बराल बाबूंकर जयवंत बाबू
हाँ yes
बराल बाबूंकर माइक्रोफोनटा अनम्यूट करंतु Mr. DJ Baral, he wants to ask something. Yes. No, Mr. Baral, please.
Yes, can you hear me? Good evening, everyone. I just wanted to add that Mr. Praharaj has indicated about nickel and cobalt, and I was part of the study which was done in 2013 and around 2012 and 13, part of the PRO, a Canadian lab, and there was very encouraging results. He rightly said, even some of the places, the cobalt would pay for everything, and the nickel, and even they were talking about some hydrometallurgical processes for getting even iron. And there is a sample test, there is a lab test, there is a bench scale test even done for this nickel and cobalt. I think we should not forget about I think at 2012 estimates, there are around 400 million tons of overburden obviously not all are sampled. Like the results from the South Kalyapani and the Tata dumps were much better. But obviously we know Kansa there is a resource report still available for nickel. So I think with this discussion I just wanted to get attention about nickel cobalt, rightly pointed out by Mr. Praharaj. Thank you.
Thank you. Professor
Can I-
Sahu, yes,
Can I come in?
yes, please do.
Sahu here. Before I come to the nickel, which I have been working for the last 30 years on Sukinda nickel, let me tell you that for looking for platinum, IIMT, that is RRL, which I started in Bhubaneswar, tried to look into the platinum of Baula or ultrabasic rocks. As a matter of fact, there was a sample in which one Mr. Ramsaran Sahu, the scientist of IIMT, showed me when I visited the laboratory a very a small shining speck, considering that they could be platinum. When about 20 years before, I had taken 5 Canadian scientists to Bhubaneswar, where one of the famous scientists delivered a lecture in Sagat, SGAT, when PK Mahanti was the director. And they gave us, to the Canadians, my friends who are visiting with me, 10 samples for analysis of platinum in Sukinda material. The 10 samples were sent to Canada through me, but unfortunately, Canada in Western Ontario University, unfortunately, the gentleman who was looking for it, analyzing it, died, and the work stopped at that point. In the meantime, Mr. K.S. Ramachandran, your OMC, big starter of OMC, once told me a few years before that they were also trying to look into the platinum in Bola ultrabasic, but they have not been able to find it out. Whereas for the nickel, people have done excellent work for 30, 40 years. Work has been done, and it has a potentiality of a large amount of nickel content. Myself, I have investigated with 2 PhD, 5 MTechs, 4 MSc on Sukinda materials regarding nickel concentration. And we had a nickel committee of Government of India some time before, beginning of the 2000. They had moved around India in different places, and we have even gone to IIMT, and there are 5 high committee for important persons, all scientists, one from HCL, one from Baba Atomic Research Center, one myself from IIT, and another gentleman, I'm forgetting the name. We met in Bhubaneswar in IIMT, and it was started in IIMT to extract nickel. One Dr. Das, I know they extracted, even HCL, extracted a sheet of nickel out of it. But till today, no work has been done on the nickel processing. My observations on the nickel concentration of Sukinda material is I have conducted by labor experiment for 8 years on that material with variety of equipment using, and I found that the nickel is distributed in partly in the amorphous stage called goethite and partly in the clay called moldonite. Since it is divided into two minerals in the altar products, it's very difficult to separate these two and extract the nickel out of it. So the matter stands at that nickel has not been able to exploit it from Sukinda material. I published 3 or 4 papers on Sukinda nickel, and I have experimented for 8 years on Sukinda material starting at Bombay. Because when I started my work in IIMT and RRL, which I started, I couldn't do it, so I left that place, but brought a truckload of materials, nickel laterite, from Bhubaneswar to IIT Bombay, and we made a lot of investigation. The difficulty is that the nickel is divided into 2 mineral phases, which are so fine, it's difficult to extract both of them and extract nickel from both of them. The material stands as that. But people have been working on it, and we have a good good hope that sometimes a nickel extraction plant will come up in Sukinda material. Thank you, gentlemen. Thank you very much.
Thank you, Professor Saab. And now, since we have a shortage of time, I'll end the entire, summarize the discussion, very lively discussion and excellent presentation by Mr. Praharaj. We could understand that there are constraints, but the constraints of the soft rock mining for underground mining is continuously being researched and being implemented. And we hope that since underground mining is inevitable and to bridge the gap between supply and demand of chromite, I am sure with another few years from now, we will be seeing the entire Sukinda Valley with full of underground mines, which we have seen for the last 50, 60 years, only open cast mines. So we will have open cast come underground mines. There may be difficulties, but difficulties are slowly, necessities are mother of invention. So we have necessities. So obviously, whatever may be the difficulty, that will be definitely addressed. And I think another 10 years from now, we will be seeing a number of underground minings in the Sukinda Valley.
Yes.
Thank you very much, everybody, for your very lively discussion. Thank you, Mr. Praharaj, again, for the excellent presentation which you gave. Thank you.
Thank you, sir. Thank you. Thanks, everybody.